right, starting with 6.5, we are going to make an outline of all the techniques that we use for factoring and basically a flow chart, if you want, based on the number of terms you have left and how you should check your factoring. So this sheet in your notes is a very good sheet to have out all the time for factoring. Number one, always check for your GCF. And what you have left over in the parentheses, that's what we're going to look at next. The number of terms in your leftovers, in your parentheses, determine which step we go to next. So if there are two terms left over after I take out the GCF, I'm going to go to step 2. Now there's two rules. We had the difference of perfect squares and perfect cubes, and if you recall, we said always do the difference of perfect squares first. Perfect cubes are done second. Again, I'll tell you why we do it in that order in just a minute. But we have a squared minus b squared, that's equal to a plus b, a minus b. Take the square root of each term, 1 plus 1 minus. Now remember, these binomials like to hide in your leftover answers, so you may have to always come back to step 2. So if you ever get an a squared or x squared, x to the fourth, once you're done factoring, consider you may have a difference of perfect squares. Perfect cubes, this is where we built the binomial and the trinomial, and we said we're going to soap our signs. This first sign in the binomial is always the same as what's over here, so if you have a plus, this is a plus. If you have a minus, it's a minus. This first sign in the trinomial is always opposite of what's in the binomial, so if it's plus, then it's a minus. If it's a minus, it's a plus. That's why I flipped this over. AP, always plus, is the last. So again, we build the binomial. You take the cube root of a cubed is a. You put it in the first blank of the binomial. You take the cube root of b cubed, put it in the second blank of our binomial. And then you smile. Remember, we build the smiley face. A times a squared. A times b, ab. B times b, b squared. And if you remember when we talked about this trinomial is never going to factor down to two binomials. That's why we do difference of perfect squares first, perfect cubes second. Because if you did this first, we won't be able to factor this down to get to our difference of perfect square answers. All right, to step 3. If there's 3 terms in this leftover, then we're going to jump down to step 3. This is when we had our ax squared plus bx plus c. Remember, we're going to use our sign rules. If this is a plus, then the two signs are the same. It's the sign of the middle term. If this is a minus c, then it's 1 plus 1 minus. Remember, we always use this a twice when we write down what our answer looks like. So I'm going to base it off of this plus at the c, and then a plus in the middle term. So ax plus something, ax plus something. Then we used our ABC rule for factoring. What two things multiply to be AC and add up to be B? This is where we used our even and odd rules. Remember, if it's an odd, break down. If B is odd, break these down. Find your individual odd factors. Make your odd possibilities. If this is even, look for one of your A or C's to be even. Then take out your 2's. If B is even and both of these are odd, then it's listing your odd factors. So we find our numbers, let's call them D and E, we put them in the appropriate blanks, we take out the GCF of each binomial, and that's our final answer. Now, if you take out the GCF and there's 4 terms left over, then we do factor by grouping. We cut it in half. You build a binomial on the left, the binomial on the right. Remember, these two binomials have to be the same. So when you take out the GCF of the left and you create this binomial, it has to be the same over here. So just copy it over, take out the GCF on the right. These two come out to be the same binomial, and one answer, GCF of the left in the left blank, GCF of the right in the right blank, and then it's factored. Now, that we finished step 3, we had that one special type of trinomial. We called it perfect square trinomials. First term perfect square, last term perfect square, and we had that middle term was created by multiplying after you took the square root of each term. So when this happens, we're going to call this the Sesame Street problem. You have 4 terms, and one of these things is not like the other. I have x squared, x to the first, my constant, my normal trinomial. Why is this minus y squared here? This is a 3-to-1 split. Isolate the minus y squared. Take this trinomial. It must factor to a binomial being squared. If it does, then you have a difference of perfect squares, which we will factor this binomial plus y, this binomial minus y, and that's my answer. Now this could be a 1-to-3 split where it's y squared minus all these terms with minus signs. And when we get to an example, I'll point that out so you can see it. All right, time for examples. Factor completely. There's that word. Start with your GCF. I see a 5 that can be divided out of both terms. Move that out to the front. Divide it out, x to the 14th. 80 divided by 5 is 16. It's wait a minute. Even power. 16 is a perfect square. This is a difference of perfect squares, DPS. Take the square root of x to the 4th, that's x squared. Take the square root of 16, that's 4. 1 plus, 1 minus. Wait a minute. Perfect square, I'm subtracting. This factors one more time. See, this is where this binomial, a difference of perfect squares, likes to hide in your answers, and we have to factor it one more time. Always put the plus first, minus second. So this is the last thing you're writing, and hopefully we'll see that. It's a difference of perfect squares. X squared plus 4 doesn't break down. You got to have a minus sign here. So only this one breaks down. That's my final answer. Over here, holy cow, 4x to the 4th plus 10x to the 3rd minus 36x squared minus 90x. X is in every term. Every number is even. I'm taking out a 2x to the lowest power of 1. Factor that out as the GCF. I have these 4 terms left. So now we just got step 1 done. Now we have to jump down to step 4 on that note sheet. So focus just on the inside. My recommendation is take this 2x, go put it in your answer, then ignore it. We cut the inside in half. This forces the GCF to be x squared. Don't get it confused with the 2x and the x squared. Don't multiply these together. 2x plus 5 is my binomial. It has to be the same over here, so negative 45 divided by 5 is negative 9. So the 2x plus 5's come out to be one binomial with that GCF of 2x still out front. X squared minus 9 makes the second. Wait a minute. Doggone it. There's another difference of perfect squares hiding here. If you would have looked up here, you never would have thought you had difference of perfect squares in this problem. Now that we factored out, that factors to an x plus 3, x minus 3. These we leave alone. All right, let's see. We have 3, 3, 24, 24. So I see a GCF of a 3. No x, though, just the 3. So I factor that out. Again, just like with the 2x, you could write this down in your answer and ignore it. Cut this in half on the inside, factor by grouping. I take out an x cubed this time. That's the smallest power on my x. That leaves me x squared minus 1. I have to have an x squared minus 1 over here, which forces my GCF of the right to be a minus 8. These two x squared minus 1's, I have to finish my factor by grouping. Even though they're difference of perfect squares, they're going to come together as one binomial. X cubed minus 8 is my, wait a minute, difference of perfect squares, perfect cubes. Holy cow, we got to go back to step 2. We went from step 1 to step 4, and now we got to go back to step 2 and do difference of perfect squares and perfect cubes. So x plus 1, x minus 1, difference of perfect squares. Binomial, trinomial, keep the same sign, opposite sign, always plus. Cube root of x cubed is x. Cube root of 8 is 2. X times x, x squared. X times 2, 2x. 2 times 2, 4. Now it's fully factored. This is a trick question. X to the 6th minus 64. We saw this before when we did perfect cubes. 64. X to the 6th and a 1. both difference of perfect squares and perfect cubes. So we have to do difference of perfect squares first. So the square root of x to the 6th is x cubed. Square root of 64 is 8. 1 plus 1 minus. Holy moly, now we have perfect cubes twice. 1 for each one. Binomial, trinomial, binomial, trinomial. Cube root of x cubed is x. Keep the same sign, minus. Over here, minus plus. Remember, when you build this binomial x, build this one as well. Cube root of 8 is 2. Put a 2 here. X times x, x squared, x squared. X times 2, 2x, 2x. 2 times 2, 4, 4. That's my final answer. Factor completely. We have 7x squared plus 35x plus 42. Wait a minute. We have a GCF of a 7. Factor that out. I now have 3 terms. Go to step 3. All right. Plus 6. Same signs. Both plus. What two numbers multiply to be 6 and add up to be 5? We can use that shortcut because there's a 1 in front of my x squared. That's right. Plus 3 plus 2. Now I'm completely factored. All right, over here, holy, lots of x's. X squared, and I believe 3 can go into both 30 and 72. Factor that out. I'm left with x squared minus 10x minus 24 after I divide out a 3x squared from each term. All right, we have a 1 in front of our x squared. We can use our shortcut. It's a minus, so 1 plus 1 minus. What two numbers multiply to be 24 and subtract to be a 10? That means one number's bigger than 10. I'm thinking 12 and 2. 12 carries the minus sign. 2 carries the plus sign. Now we're completely factored. Now we have x squared plus 6x plus 9 minus y. What? Oh, here's that special factor by grouping. One of these things is not like the other. Isolate the minus y squared. So x squared plus 6x plus 9 has to factor to a binomial squared. I'm guessing x and a positive 3. So just to double check, x times 3 is 3x, double it, there's your 6x. This is a perfect square, this is a perfect square, and I'm subtracting. So difference of perfect squares gives me x plus 3 plus a y, x plus 3 minus a y. I always write it with the parentheses first, and then since nothing's being multiplied, you can remove the parentheses, and these two trinomials are now my answer. Here it is, 1 to 3 split. Y squared, I use the same terms, but now my x squared, 6x, and 9, they're all minus signs. So we're going to factor the negative 1 out of just those 3 terms to create this perfect square trinomial, which is just like that. So this factors to an x plus 3 squared. Again, that's a difference of perfect squares, so it's going to be y plus this binomial, y minus that binomial. And again, use your parentheses. Really don't need them here, but this is the trick right here. This minus sign must be distributed to both terms. So when they want you to simplify it, it's y minus x minus 3. I guarantee you'll forget to change the sign on the 3. It'll mark it wrong. Go check that last sign on the minus sign. All right, so there's section 6.5.